Hello everyone, I am going to talk about aircraft propulsion. Under this, we will be studying about classification of gas turbines and analysis of open cycle gas turbine. What are the gas turbines? Gas turbines are the prime movers which is used in the aircrafts, and it is producing the mechanical energy by burning the fuel in the combustion chamber. The applications of gas turbines are many. Like it is used in aircraft vehicles, in automobile units, and in the industries also we can use these engines, and in for producing the electric energy also we can use these engines. In the classification there are two types. One is constant pressure gas turbine, other one is constant volume gas turbine. Under constant pressure combustion gas turbine, we can have two types. One is open cycle constant pressure gas turbine, other one is closed cycle constant pressure gas turbine. In open cycle, the gas after combustion will be left to the atmosphere, but in closed cycle it will be again recirculated to the compressor. This diagram shows the working of a gas turbine. It is an open cycle constant pressure gas turbine. As we can see, the exhaust gases at point number 4, it is left to the atmosphere, and fresh air will be taken to the system from the atmosphere. The beginning of the process is from compressor. The compressor takes the air from the atmosphere and it will compress the air to a higher pressure, and it will be then sent to the combustion chamber, where fuel is also added to the combustion, and the fuel gets combusted and the exhaust gases will be sent to the turbine. This exhaust gas will be having higher pressure which gets expanded, and this pressure energy gets converted into kinetic energy, which is used for producing the work, that is W net. This work is used for the running of compressor as well, and the exhaust gases will go out through the nozzle in the aircraft engines, in the jet engines, and these exhaust gases will be having some amount of pressure which produces the thrust. This is a PV diagram and TS diagram of the same process, which is known as a Brayton cycle. In this we can see the different processes. There are two adiabatic process and two constant pressure or isobaric process. In the first process, that is in the compression process, from point number 1 to 2, it is assumed that the entropy remains constant, that is S is constant, and from 2 to 3 at constant pressure the fuel is getting added to the combustion chamber, and from 3 to 4 the gas expands in the turbine at constant entropy, and finally the gases will be given out of the system at point number 4. The same process is also shown in the TS diagram. You can see a straight vertical line from point number 1 to 2 as well as from 3 to 4, which shows the constant entropy line. The actual process will not occur according to the assumptions. It is impossible to achieve a constant entropy process in nature. So always the entropy keeps on increasing. It will not be constant. So some modification we can make to the original TS diagram for getting the actual cycle. In this diagram you can see the line 1, 2, 3, 4, 1 shows the actual cycle, and 1, 2s, 3, 4s, 1 shows the ideal cycle. Why this happens is because in the compressor, when the gases gets compressed, there is a little bit increase in the temperature, which causes the increase in temperature, because of which we cannot maintain a constant entropy in the process. Similarly, in the turbine also the entropy goes on increasing when the gases are expanding, so entropy is not constant in that case also. Thank you.